Hello guys, welcome back to the Math Club. This is Paul Ayok, your mathematics instructor. Today, I want us to look at a concept that is very important in mathematics exam, the concept of differential calculus. Differential calculus is all about analyzing small changes of variables along a curve. And in doing that, I have chosen IB Mathematics Analysis and Approaches past paper of May 2022. So on the board, we are given that consider the equation y equal to 2x minus 1 e raised to the kx, where x belongs to elements of real number and k is elements of rational numbers. The tangent to the curve at the point where x equal to 1 is parallel. This is parallel. It's parallel. It's parallel to the line y equal to 5e times x. Find the value of k. So join me and let's look at the solution together. So we are given that our curve y equal to 2x minus 1 e to the kx. So the first thing is for us to find the gradient of the tangent to this curve. So the gradient of the tangent, which is I can call MC, the gradient of the tangent to this curve is your dy on dx, which can be obtained as, now these are two functions that are multiplying. In differentiating two functions that are a product, we just apply the product rule, and it is shorter to apply the product rule by saying you differentiate this function and keep this one, then later on you differentiate this other function and keep this one. So the differential of 2x minus 1 is actually 2, because the differential of negative 1 is 0. The negative 1 is a constant. Its differential is 0. The differential of 2x is actually 2 because the differential of x is 1. The differential of x is 1 multiplied by 2 is 2 e to the kx plus. If you notice very well, I differentiated only this term. I kept this term. Then now I am going to differentiate this other term, this other function, and keeping this one. So the differential, so I will have 2x minus 1. What is the differential of e? What is the differential of e exponent kx? To differentiate anything that has to do with e, just differentiate the exponent on e and multiply it behind the function itself. So the differential of kx is actually k. So you multiply the k behind the function itself. So each time you see e exponent any expression, just differentiate the exponent on e and multiply it behind the original function. So my gradient of the curve is actually, you can see e exponent kx is a common factor, so you factor it out. So I have e exponent kx, all that into 2 plus 2x minus 1 times k. So at x equal to 1, they told us that the gradient to the tangent, the tangent to the curve at the point where x equal 1 means at x equal 1, our MC, the gradient to the curve at that point will be, we are going to be replacing x as 1 everywhere in this expression. So we have e, replace x here as 1 will be k into 2 plus, replace x here as 1 will be 2 times 1, 2 minus 1, 1 times k will be k. So you see that the gradient of the curve at x equal to 1 is actually e exponent k into 2 plus k. Then they also told us that that gradient is parallel to the line y equal to 5e exponent k times x. when two curves or when two lines are parallel, their gradients must be equal. So for the line y equal to 5e exponent k times x, the gradient of the line is actually the coefficient of x. If you recall the general equation of a line, the gradient of the line is the coefficient of x when y is isolated. Once you isolate y, the gradient of the line is the coefficient of x. So the gradient of the line ML will be 5 exponent k. So I can say since from y equal to mx plus c, you see that m is the gradient. So that is why I took this coefficient as the gradient of a line, because it is the coefficient of x, just like from the general equation of a line, m is the gradient and is the coefficient of x. And they told us that they are parallel. The gradient to this line is parallel to the gradient at this curve. So if they are parallel, then the gradient of the curve should be equal to the gradient of the line. The gradient of the curve should be equal to the gradient of the line at that point x equal to 1. So it means, therefore, that e exponent k into 2 plus k should be equal to 5 exponent k. You see that e exponent k and e exponent k can cancel on both sides. So 2 plus k should be equal to 5. So I will subtract 2 on both sides. 2 minus 2 in order to isolate k should be equal to 5 minus 2. So these guys, they cancel out. This implies my k will be 3. So as you can see, the value of k that they were asking us to find is actually 3. So if you are seeing me for the first time, like, subscribe, because you might not see me again. So subscribe, share, like, and comment so that for my next update, you'll be receiving my videos. See you.